All right, so let's talk about the angle addition postulate. So the angle addition postulate is the angle version of the segment addition postulate, which tells us if P is in the interior of RST, then the measure of angle RST is equal to the sum of measures of angle RSP and PST. So if P is on the interior, then the measure of angle RST equals the measure of the angle RSP plus the measure of the angle PST. So the two little angles add up to the big angle, is what we're saying. And the measure of RST is right here. It's this whole thing. That's what this graphic is showing us. Well, let's see how that actually will work. So given that LKN is 145 degrees, here's LKN, the measure of LKN. Find the measure of angle LKM right here, and the measure of angle MKN, which is right here. So based on the angle addition postulate, we know that the measure of angle LKN equals the measure of angle LKM plus the measure of angle MKN. So measures of angles are numbers. Let's use them like a number. So that means we can add them, subtract them, divide them, substitute for them. We can subtract them from both sides of an equation. We can do anything that we can do to numbers to measures. So we know the measure of angle LKN is 145 degrees. So let's substitute that in. We know that the measure of angle LKM is 2x plus 10. So let's substitute that in. And we know that the measure of angle MKN is 4x minus 3. And let's go ahead and solve, just like we've been doing since about 5th or 6th grade. So first thing we're going to do, we have lots of x's and numbers over here, so we're going to combine like terms. So 2x plus 4x is 6x, 10 minus 3 is 7. We're going to get the x by itself. And then we're going to divide both sides by 6, and we're going to end up with x equals 23. Well, we've been asked to find LKM, the measure of angle LKM and the measure of angle MKN. So we are not done yet. So the measure of angle LKM equals 2x plus 10, because like I said before, it's just a number. And then x equals 23, so we can substitute that in. So the measure of angle LKM equals 2 times 23, which is 46, plus 10 is 56 degrees. Now we're going to solve for the measure of angle MKN. And the measure of angle MKN is 4x minus 3. Well, x is still 23, and 4 times 23 is 92, minus 3 means that the measure of angle MKN equals 89 degrees. And 89 plus 56 equals 145. So we're good to go. Let's do another example together. All right, so PQR is 102, and here's PQR. Here's S, or PQS, which is this one. And here's SQR, which is this one. So let's start off at the very beginning. The measure of angle PQR equals the measure of angle PQS plus the measure of angle SQR. Well, we know PQR is 102, so let's substitute that in. We know that PQS is 7x minus 5. So let's substitute that in. And we know that SQR is 9x plus 11. So let's substitute that in. So once again, we got a bunch of x's and numbers on the same side. So we're going to combine like terms. 7x plus 9x is 16x, and 11 minus 5 is 6. Oh, that's a plus 6, which will make these minuses. Make sure I get my signs right. So 96 equals 16x. Divide both sides by 16 and we get x equals 6. So once again, let's plug it in and find the measure of SQR and the measure of angle PQS. So the measure of angle PQS equals 7x minus 5. X is 6. So we got 7 times 6 minus 5. And the measure of angle PQS equals 7 times 6 is 42, minus 5 is 37 degrees. Now let's find the measure of angle SQR. That equals 9x plus 11. So 9 times 6 plus 11. 9 times 6 is 54 plus 11 makes the measure of angle SQR 65 degrees. And 65 plus 37 equals 102. So we're doing well. All right, so now you're going to have to remember some stuff that we had talked about previously. Go ahead and solve this problem. Stop the video, solve the problem, and then start it back up and see how you did. All right, so KLM is a straight angle. Straight angle is 180 degrees. So we know that the measure of angle KLM equals 180. Find the measure of KLN, angle KLN, which is this guy right here, and the measure of NLM, which is right here. So the measure of angle KLM is the measure of the two smaller angles added together. So the measure of angle KLN plus the measure of angle NLM. Well, the measure of KLM is 180 degrees. The measure of angle KLN is 10x minus 5. And the measure of angle NLM is 4x plus 3. So we got some x's and numbers on the same side, so we're going to combine like terms. And negative 5 plus 3 is negative 2. Then we're going to get the x by itself. We're going to divide both sides by 14, and x equals 13. So let's go ahead and find KLN. So the measure of angle KLN equals 10x minus 5. X is 13. So 10 times 13 minus 5, which makes the measure of angle KLN. 10 times 13 is 130, minus 5 is 125 degrees. One down. Let's find the measure of angle NLM, which is 4x plus 3. X is still 13, so 4 times 13 plus 3. So the measure of angle NLM equals 4 times 13, which is 52, plus 3 is 55 degrees. Let's double check. 125 plus 55 equals 180. All right, we're feeling pretty good about the work we just did. So for this one, I forgot to put in the other angle. So go ahead and pause the video, solve the problem, and then restart it, and we'll see how you did. All right, so angle EFG right here is a right angle. There's a little right angle box. So we know that it's the measure of angle EFG equals 90. EFH is this one right here. HFG is this one right here. So using our handy-dandy angle addition postulate, we know the measure of angle EFG equals the measure of angle EFH plus the measure of angle HFG. The measure of EHG is 90. The measure of angle EFH is 2x plus 2. The measure of angle HFG is x plus 1. So we're going to combine our like terms. So 2x plus x is 3x, and 2 plus 1 is 3. Then we're going to get our x by itself. And 87 equals 3x. 3 divided by both sides, x is going to equal 29. So let's find the measure of angle FH, which is 2x plus 2. So x is 29. 2 times 29 is 58 plus 2 equals 60. So the measure of angle EFH is 60 degrees. Now let's find the measure of angle HFG. And that equals x plus 1. X is still 29. So the measure of angle HFG equals 30 degrees. And 60 plus 30 equals 90, which is what we started with. So we're feeling pretty good about things. All right, so the last thing we're going to talk about is an angle bisector. So if we recall back to when we talked about a segment bisector, the segment bisector is a point line segment, or ray that goes through the midpoint of the segment. Essentially, it cuts the segment in half. So the angle bisector is going to cut the angle in half. So the technical definition is an angle bisector is a ray that divides an angle into two angles that are congruent. And as we recall, congruent means same measure. So angle array YW right here bisects angle XYZ right here. So what does that mean to us? That means that angle XYW is congruent to angle WYZ, and the measure of angle XYW equals the measure of angle WYZ. And here we have these two little arcs, which tell us that they're congruent, and they're offset to show that they're dealing with separate angles, because these little arcs, where they start and stop, is the angle they're talking about. So sometimes we're going to have an arc that does this, and let's just say it's 75 degrees. That means that the measure of angle XYZ is 75 degrees. So we got to make sure we know what they're talking about, because this right here means congruent. So let's look at a couple examples and how we would apply this in the work that we're doing. So ray QS bisects angle PQR. Let's stop there. Let's get this going and find out what we're dealing with. So we have angle PQR, P, Q, and R. And we have a ray QS that bisects it. So ray QS, we have the Q down here already, so we need an S. And don't worry if your sketch isn't to scale of what the numbers actually come out to. This doesn't matter. This is just a visual assistant to help us to keep track of what's going on. So it bisects it, so it cuts PQR in half. So PQS and QSR are congruent angles. So we learned all of this right here, from those first few words. Okay, so let's continue on. Let's do this one. PQS is 24 degrees. So right here is PQS, and it's 24 degrees. Okay, find the measure of PQR, which is going to be this whole thing. So I always like to start at the beginning. What do I know about PQS? Well, I know that the measure of angle PQS equals the measure of angle SQR, because angle PQS is congruent to angle SQR. I also know that the measure of angle PQS equals 24. So if PQS is 24, I can substitute in 24 for PQS right here and get 24 equals the measure of angle SQR. Oh, well, that's pretty simple. And then go back to my angle addition postulate. I got to find the measure of angle PQR. So the measure of angle PQR equals the measure of angle PQS plus, need a little bit more room, move this down, the measure of angle SQR. So the angle of measure PQR, well, the measure PQS is 24, that was given. So let's substitute that in. We showed that the measure of angle SQR is 24, so we can substitute that in. So then we just combine our like terms, and the measure of angle PQR equals 48 degrees. Let's look at another example. Let's do it again. So once again, we're going to stop right here and see what we have. So we have angle AVC. Let's draw angle AVC. AVC. Ray VB. Here's my V. So I need a B here, or about there. It's not to scale, so I'm not too worried about it. Bisects my angle, which makes these two the same. And the measure of angle AVC is 158 degrees. That's the whole angle. So what do I know? I know that angle AVB is congruent to angle BVC, so therefore the measure of angle AVB equals the measure of angle BVC. They're equal. I know from my segment or my angle addition postulate that angle AVC equals the measure of angle AVB plus the measure of angle BVC. So what am I supposed to find? I'm supposed to find the measure of angle BVC. So I want to have just BVCs. Well, what do I know about AVB? I know that it equals BVC, so I could substitute in BVC for AVB. So the measure of angle BVC plus the measure of angle BVC equals the measure of angle AVC. Well, I have BVC plus BVC. And that's very similar because they're both numbers, as if I had x plus x would be 2x. So I get AVC equals 2 times the measure of angle BVC. Well, I know AVC is 158, so let's substitute that in. Then I can divide both sides by 2, and 79 degrees equals the measure of angle BVC. And we are done.